Hello friends. So today we are going to discuss about the topic setting up development environment. Setting up development environment for the Node MCU ESP8266 involve configuring the necessary software tools and library to program and interface with the board. To perform any type of function, to perform any type of processing, we have to configure, we have to set up a developing environment for Node MCU. The table of contents which we are going to cover in this presentation is introduction, hardware setup, software installation, hello world blinking LED, Wi-Fi connectivity, GPIO, web server and web controller, MQTT communication, OTA over the air updates. So introduction, how to program Node MCU with Arduino IDE. Setting up a development environment for Node MCU ESP8266 involve configuring your computer to write, compile, and upload code to the Node MCU board. It installs Arduino IDE or a platform where you need an integrated development environment to write and upload code to your Node MCU ESP8266. You can choose between Arduino IDE or a platform IO, both which support ESP8266 platform development. And Arduino IDE is a beginner friendly and widely used. Download and install it from the official Arduino site. Platform IO is more advanced and powerful development platform that integrates with popular code editors like Visual Studio Code. You can install Platform IO as an extension to your chosen code editor. So it is basically the introduction how you choose Node MCU board and how you combine that Wi-Fi module and microcontroller unit. The compact board empowers you to create a connected device, gather sensor data, actuators, and interact with the cloud devices. However, before diving into a project, it is essential to establish a solid development environment. Hardware setup. Hardware setup is basically here is a given the introduction about the Node MCU. What are the different kind of pins and holes are available to whom you have to set up. So you have to select the your installing board and the board package. You have to select the Node MCU board, whatever the board you want to use. It can be anything. And you have to install the package regarding it, like whatever the package is required to configure with it, you need that. So there is a variant, you have a listed of supported boards. You can usually find it under Node MCU or a similar name. Installing the USB driver is also needed. Software installation, like Arduino IDE platform, you have to need where you perform all the codings there, like whether you are doing the programming in C programming or a Lua programming, that you can do there from software installation. Coming to the Hello World blinking LED. This is the basic program that we need to check whatever the connection we have made with LED resistors and Node MCU within the breadboard, is it proper working or not? That is the first program that we are using here. It's the Hello World blinking LED, where that we perform the blinking action by uploading the code within the Node MCU board. So we have to test it. Basically, it is used for testing purpose. Wi-Fi connectivity, we have to check that whether our internet have been connected properly or not. Like we have to start, we have to know our Wi-Fi, we have to collect that hotspot, and if it is connected properly, your code will be functioned in a proper manner. GPIO pins, journal input output pins, they are very basic important pin that is used for the integration. Whatever the sensor or board you are connecting with it, that GPIO pins help you to understand with that. That help us to integrate and modify your Node MCU. Web server and web control. So coming to the web server and web control, it's a web server referred to a creating a web-based interface to interact with it with Node MCU or a web connected other connected device. Like web server is a software application or a component that serve web components to clients, typically web browser. So Node MCU can turn Node into a web server, allowing it to listen for incoming HTTP requests and respond from web pages, data, or commands. Node MCU can host a web server to serve web pages, provide data, or even control connected devices. Web control is the context of Node MCU, and IoT refer to the ability to interact with and control devices or system using web-based interfaces. These interfaces can be accessed from a web browser on a computer, smartphone, or any devices with internet connectivity. Node MCU based projects often implement web control to allow user to perform action such as turning on a flight, adjusting temperature settings, monitoring sensors. So Node MCU web servers serve web pages that contain these user interfaces elements. Coming to the MQTT communication, message queuing, telemetry, transport communication. You can see here the diagram what how this MQTT communication happens. It's a lightweight and efficient messaging protocol designed for reliable communication between IoT devices and applications. It published subscribe model that allow two main entities, publisher and subscriber. Device that generate data or messages are called publisher. They publish data to a specific topic, and subscriber device or application interested in a specific subscribe to those topic. Receive messages published to the topic they are subscribed to. Broker facilitated by the central component. Quality of service level are there. Retained messages have been maintained. So basically used in IoT application to enable devices to communicate with each other and with the cloud-based service. It's especially useful for scenarios where low bandwidth, low power consumption and reliable messaging are crucial. Over the air updates, OTA. It's a refer to the process of remotely updating the firmware or software of a connected devices. Here is an example given. What is OTA programming have been used here? Use of OTA and upload LED blinking using OTA. So remote updates are there to remotely deploy new firmware or software version to IoT devices without requiring physical access to the devices. Efficiency OT updates are designed to be efficient in terms of data transmission instead of sending the entire firmware image updates typically. So OT update system often include mechanism for rollback in case an update causes issues or fails. Schedule updates, version management is there. OT update system may use redundant servers or multiple paths for delivering updates and IoT to keep devices secure update. Basically, OT updates allow for remote and secure firmware software updates, enhancing the functionality and security of connected devices. These concepts are very important for the IoT ecosystem. So these are some of the concepts that have been used in our Node MCU ESP8266. I hope you are able to understand this. Thank you guys and have a nice day and happy coding.